glad to have you all still here with us. So indeed, I'm planning to show one example related to last week's exercise that might help you to further understand the grouped objects in Pandas and how to get information out of there to a new data frame. I'll show that just in a bit. And maybe, hopefully, most of you saw that we decided to extend the deadline for exercise 6. So if you already submitted but are a bit confused or still want to ask something, so you have time until Friday this week to update your solutions. So this should allow you to ask questions in the exercise sessions and also now, of course. So indeed, this grouping objects and iterating over the groups, taking averages and so on, it's kind of a new concept. So you need to practice it a few times to understand how it goes. And I'll show now one example related to that. And indeed, week 6 is traditionally perceived as a challenging one, but hopefully it's challenging in a good way so that it enables you to actually also challenge yourself, learn a bit more things that you can't just maybe Google and copy paste. So you actually need to understand what is going on when you're aggregating the data and finally calculating the anomalies. Yeah, so indeed there is a bit of a jump, and also I think exercise 6 contains some of the topics that we will cover actually today, such as deleting or getting rid of no data values and so on. So now as we are dealing with real data, we want to get some actual insights out of there. So then the kind of toolbox we need to use, it's kind of growing to be massive. And that means that you need to also Google yourself, read the documentation. But at this point, you should be able to adopt new methods based on Pandas documentation of other packages. So you are ready for that. Don't worry. Yep, and indeed, it probably took you more time to complete the exercise, but that's how it goes. So maybe in weeks 1 and 2 you didn't spend the full 4 hours working on the exercises, but this week might have compensated for that. Okay, then there were some. I can't really see on this screen. Is there going to be an exam? What happened after the end of classes? So indeed we'll talk about it a bit more maybe after the lesson, but we have this final project that comprises 40% of your grade. So now these weekly exercises have allowed you to learn, discuss with your pair, come to the exercise sessions and to learn the methods. Probably you most have done very well in the exercises, and based on the grading scheme, if you complete all the exercises, those sum up to 60% of the grade. And then in addition, you need to show in this final project that you can individually then apply these skills. So maybe Dave can continue explaining the final project in a bit, but it's basically repeats the things we have learned so far, but using a bit different input data and a bit less instructions.
Yeah, Bokeh, there was just a question here about the not being able to see the lesson 7 materials, and I posted something in chat as well about this, but I'll just say that it seems like the page was a little bit slow to build this morning, so it is building. It should be up soon, but it might take us a couple minutes. I don't know why it was slower than normal, but of course, when we decide we want to make the page available to the public later than normal, that would be the time when it's going to take more time than normal to build, but it should be ready soon.
Yep, and maybe going forward to when we start with the lesson, we again recommend that you use the CSC Notebooks Lite version, so the notebooks are available there, but indeed, we recommend you launch the blueprint, which has this light in the name, which isn't linked to the persistent storage. Was there some questions we didn't now address? If we want to continue to AutoGIS, do we need to have passed everything with a full score? So of course you can, the default is that you continue straight. So the deadline for the final project will be in 3 weeks. So you will get the grades from this first teaching period later on. And we basically continue where we left, where we leave the things this week. So everybody is welcome to follow the automating GIS processes straight after this course. Previously, it used to be one course with 10 credit points, but this year we have separated us to two course codes for admin reasons. Okay, would now be a good time for me to show a piece of code related to exercise 6, or was there something else? What do you think, Dave?
I don't know if there was one other question that maybe came up in the first poll question here about possible to have the answers to the problems. I don't know if that was up a moment ago when you started talking about this, but in general, we've been a bit hesitant to circulate the solutions to the problems just because we don't know where they will ultimately end up. Of course, if you want to know whether your code is correct, maybe the easiest thing to do is to either contact Bokeh or myself in Slack, or whoever graded your exercise. You can also ask questions to them. Of course, that's only really after the fact, when the assessment has been done. But even if you have questions along the way, it's normally okay to check in with one of the graders or the instructors in the course and just see if you're on the right track. We try to provide these tests and things that allow you to see in some sense that your code is doing the right thing, but of course we can't do that for every situation. And in some cases, in order to not give away the solution, we have to make the tests general enough that maybe you're not sure whether you have the right code. But you can always check with one of us or say like, hey, can you take a look at my GitHub and see whether this looks like it's the right solution? And I think none of us, as far as I know, have any objections to those kind of things.
Yep. So of course we can share maybe code snippets on Slack if there was some difficult part. And I would encourage you to be active and use especially the exercise sessions to discuss the details of the exercises. Then there was, is there going to be weekly exercise 7 plus final project? Yes, there will, but exercise 7 is now quite short. It will help you to understand the basics of plotting that we'll discuss today. And then you'll get to plot some more in the final project. So they sum up, or then the amount of work sums up quite nicely in those two. But how about if I now spend maybe 5 minutes showing the code snippet that I was planning to? Okay. Yep. So I pulled up, I hope I'm still sharing the correct screen. So I have here now the notebook from lesson 6, advanced data processing with Pandas. And this is the part where we had done, it starts from grouping the data up here. So I have this data frame. Let's actually check how it looks like. I have a data frame with information, station number, there's some observations, and then I have created this year month column with information of the month and the year in order to then group it later on. And then indeed I group the data by this information of the month and the year into this grouped object, right? So this is a bit similar process that you had in the exercise, but with different data. Then down here, in here, then the goal was to get these monthly averages out of these columns, and we did it by grouping over each group. So this grouped object contains kind of these mini data frames, and then for each mini data frame, so this on the first round it would contain data from January 1906. I take those columns, I take the mean, which returns a Pandas series. Then I add the key, which is the information of the date or month and year. to that series, and then I append this series as one row of data to this data frame. So this is how we present it in the lesson. And if I run that, it should work. And as output, I get this monthly data. Monthly data, which then has on each row one unique value. So one month year combination and then the mean values. Okay. In the exercise, you were asked to do similar thing, but only with one average value, if I remember correctly. And in that case, I would maybe do it a bit differently. So you could, of course, have the same syntax if we want just the Fahrenheit temperature. So only one column. I still have it in brackets. And if I run this, I think this should work. And then the output contains only it takes the mean. It actually here also returns a Pandas series because I'm taking this kind of mean out of a data frame and not a series. So then that gives me a series. I add the key and then I add one row of data. But how I'm used to doing this, actually, if you only have one column, so then I would pass it. I take out the brackets. So at this point, actually, it's maybe more clear if I write it straight to here. So if I only take, you can have it in a variable, but I do it like this, so it's easier to maybe follow. So now I'm taking mean out of one column, which is a Pandas series. So then this mean values is actually a floating point variable, not a Pandas series anymore. And now, well, this will give me an error. So I will have to start modifying. Maybe I do so that I put a break in here. I hope you can follow what I'm doing. Break. So if I do like this, at this point of the process, I have this mean value. Let's call it mean value, as I only have one value. Mean value variable. So it's one number. So I have taken the groups, and then now for the first group out of the column temp Fahrenheit, I have taken the mean and stored it in this variable. So now with this setup, I can actually forget about this appending, which is a bit abstract, at least in my opinion. So I will delete all of this. And then I have now this monthly data frame that I create on the fly. And then as output, again, I want for each row, for each day, kind of month, year combination, I want the mean value. So I could do like this. Monthly data at. Then I need to give the index. If you remember this at accessor, it's similar to the lock, but now I'm kind of accessing one specific cell. So I can say that at this index, which would then be created on the fly. So at the index of this date information in column mean, that also can be created on the fly. They could exist already in here, but I haven't now created them. Assign mean value as the value. And what is going on in here? Let's see. That's red for some reason. And then actually do this. Fix my indentations. Okay. So now I have a bit shorter code, and maybe, at least to me, this is a bit more intuitive. So I create the structure or an empty data frame. I have my group data for the unique values as the group keys from the year month. Then I take the mean from each group for this column. I have it as floating point value, and then this might be a bit difficult to understand, so I refer to the key as the index. So at each iteration, the key is different, and then a new value gets inserted to the data frame. If you want to control the indices in the data frame, so then it would be a good idea to do this. So when creating the data frame, you can do, we had data, year, month, unique. So these were the unique values based on which we grouped the data. So like this, I can then control that what indices exist. And then, for example, if there was a missing value, I would still have a row for all the keys that I want in there. Okay, so this is now an alternative to the approach we presented in the lesson. And something like this, or then you might want to use lock and a condition to do something for specific number of rows. Okay, I can share this code. Maybe we should actually add this to the lesson materials, but I can share this on Slack for you. I think we did a bit similar thing when iterating over rows. So we go through the data and then we take out a value and then we want to add it using the information of the current key to the data frame. All right, so I hope this didn't confuse, but help you to understand. And if there's any questions, I'm happy to answer now. And perhaps if there are some bigger questions related to exercise 6, I'm also happy to join the exercise sessions at least tomorrow, Thursday, to go through your code if you're stuck somewhere. So indeed, this grouped object, going through it, it's a bit it's kind of an abstract thing. So I'm happy to walk you through it if you want to show your code and understand it better. All right, so that was all related to this. I can't see any questions in the chat. Let's see if there's any more questions in here. If not, I would be ready to hand over to Dave, if Dave is ready for that.
I am. So let's see. I guess if you can stop your screen share, then I can do mine. And yeah, hopefully you can see my screen now and our lesson overview for this week for lesson number 7. Just as a reminder, we did see the questions about the final exercise deadline and things like that in chat, and we'll come to that maybe at the end of the lesson. We'll talk a little bit about exercise number 7 and the final exercise as well. And before we do that, we're going to get onto our lesson material for this week, and that's about the topic of plotting data or data visualization. And we're going to be doing this data visualization using basically 2 different plotting libraries. So as you've already seen, if you remember back from the first lesson on Pandas in week number 5, we can do relatively simple plots of our data directly in Pandas. And so we're going to do a little bit of that to start. But if we want to get into slightly more, maybe having a bit more control on the plot formatting and things like that, we need to use another plotting library called Matplotlib. And this is one of the main plotting libraries for data visualization in Python, and you'll very often come across examples of plots in Matplotlib when you start searching around for these things. But essentially for this week, our goal is to teach you how to make some basic XY plots using Pandas and Matplotlib, how to manipulate different elements of the plot, and how to create the plots in the Jupyter notebooks or to save them as separate image files. So that's where we're headed. Our first stop here is going to be just a brief one to talk about some of the different plotting options that are available in Python. So here you have a nice diagram that shows essentially kind of a network of different plotting libraries that are available in Python with their names and how they're related to one another in a sense. So you can see, for instance, Matplotlib here is one of the kind of main hubs. And then there are some other examples here based on things like JavaScript or OpenGL plotting libraries that are using these different either programming languages or libraries for the data visualization. And as mentioned already, the Matplotlib library is, as it's referred to here, the grand old man of Python plotting. This is one of the original and most well-developed in terms of the diversity of things you can do with it as far as the Python plotting libraries go. And you can see that it is the sort of father, in a sense, of many of these other libraries, or I suppose mother if you want to think about it that way as well. But there are many progeny of the Matplotlib plotting library. And some of them are things that you will potentially use directly in this course. You can see, for instance, Pandas is connected to Matplotlib. Of course, we're going to use that. But there are also some things you may use in the automating GIS processes for those who are continuing on to that course. And this essentially just lays out how all of these different plotting libraries are connected. We want to highlight maybe just a few of them. So Matplotlib, of course, I've already mentioned. And if you go to the course page, you can click, for instance, on this Matplotlib Gallery. I'm just going to open a new tab with that. And here, what's nice is you can see lots of different examples of the kinds of plots that you can make using the Matplotlib plotting library. So if you know a certain style of plot that you want to create, for instance, a histogram or whatever, you can go here to the plotting library and take a look at one of the plots. So let's imagine that we did want to make a histogram. You can click on it here. And what you could see is not only an example of the image of the plot, but they also provide for you an example of how to create this plot. So if you copy paste this code into your Jupyter notebook, you would be able to reproduce the plot that is shown here, for example. So this is kind of a nice way to allow you to learn a little bit more about how to create certain plots, because you can go and you can take a look at an example. Once you have the example, you can determine, okay, how do I want to change this, or what do I need to modify to make it my preferred format of the plot, and you can go from there. But it's nice to have a place to start, and the Matplotlib plotting gallery is an excellent resource for that purpose. There's also some things here that are related to Matplotlib. As you can see, we have Seaborn, we have this base map. Base map is something that's used, that's based on Matplotlib for making maps, for example. So again, you can go to the base map gallery and see some examples of that. Seaborn is also leveraging Matplotlib for the plotting, but provides attractive statistical graphics, as it says here. Again, if you just look at the Seaborn gallery, you can see, for example, here some nice plots that are done using the Seaborn library. And essentially, it is in many ways similar to what you can do in Matplotlib, but the style is a little bit different, and certain things are handled a little bit differently with Seaborn. Let's see, we've got, yeah, so Bokeh is noting Seaborn is neat, and certainly it is. It's quite easy as well to use, for instance, the Seaborn style when using Matplotlib to get different styles of plots, but visually they're quite nice looking. We are going to get a little bit of experience using this plotting library called Bokeh today. It's an optional part of the lesson on the kind of basic plotting stuff, where we use Pandas Bokeh library that allows us to do Bokeh style plots. What's cool about Bokeh is you can do interactive plotting. So you have things where you can resize the plot dynamically within the window. You can mouse over values to see what the numerical values are for things that are on the plots. And it's a nice library for making interactive plots. And when you do them, for instance, in, well, as we'll see on the course page, but when you do these things in Jupyter Notebooks, you can actually interact with it directly within the Jupyter Notebook. And if you do things like what we do for our course page, make a web page out of a notebook, the web page also still contains the interactive plotting information. So it's nice for that. Plotly is another example where you can do interactive plotting, and Dash is something that's related to Plotly. For those who are familiar with plotting in R, there's ggplot, and then there are, for instance, here, HoloViews and GeoViews that are other possibilities for doing data visualization. The point here in introducing all of these is that there's many different options for plotting your data and visualizing data in Python, and you can essentially find a selection of things here, go and take a look and see what looks like it would work for your interests and for your purpose. And in many cases, you can find nice examples of how to use these plotting libraries and some nice example plots to get you started. Now, let's jump one more step forward. And before we go into our first plotting lesson, we do need to make sort of a brief stop here. I'm not going to spend much time on this part of the lesson today, but essentially this is a description of the different styles of plots. So we have here a list of different kinds of common data plots that you might want to produce. If you're curious what a violin plot is, for example, you can click on the link there and go and find a little bit more information about violin plot. But the main reason for stopping here is just to mention some of the names of the different elements here that are part of a plot. I mean, I think all of us know at this point that we have axes and we have some data that are going to be plotted somewhere related to the axes. The point in giving all of these names here is that these are different terms that will be used when you refer to different elements of your plot when you start modifying it, for instance, using Matplotlib. So these names are what are used as the names in Matplotlib. It might vary a little bit from library to library. Sometimes they refer to certain things with a different term. But you can see, for instance, here that the X label refers to the text that is the label for the X axis. So when you want to modify that text, you need to look for a way to modify the X label. Then we have tick labels on the X axis, the Y label, for instance, here, padding that refers to the space between the axis and where the axis label is given. You know, line that might be plotted on our plots, and text that's added here is an annotation, grid lines, ticks, a legend. All of these different things on this example plot are just labeled here so you have some reference to use when you want to go and modify the plots that we start generating today. And you can also find here, for instance, a list of the common plotting terms. We will, we have it on our to-do list that we would eventually provide a version also of these terms in Finnish, just to be complete here, and potentially a version of this figure also with the values all labeled in their Finnish language equivalents. But at the moment, we only have them available in English, but we're working on that. So yeah, those are our pieces of the plot and the different styles of plot. And this is kind of just a reference page for you to go back to and look through when you have an interest in exploring different kinds of plots and how to modify different elements of the plots that you're creating. Okay, with that, I am going to go not here to the Seaborn or Matplotlib libraries, but rather here to the CSC notebooks. I have opened up an instance using the Geo-Python Lite. And as Bokeh has already mentioned, if you haven't opened your CSC instance already, we would encourage you to use the Geo-Python Lite for this lesson, just so you don't fill up your disk space on your other Geo-Python instance where data is stored between week to week. We're going to go here to Notebooks and into L7 for lesson number 7, and we're going to start here with our Matplotlib lesson just by double-clicking on the notebook name there. So as mentioned, we're going to start out with our data visualization using Pandas, which is built on top of Matplotlib. We mentioned earlier, maybe a few weeks ago now, that Pandas uses this library called NumPy in the background. We don't really see it, but it's essentially used behind the scenes for things related to how the data is stored and manipulated in Pandas. And similarly, the Matplotlib library is used in the background for how the plotting can be done directly in Pandas. And we can do a fair amount of things with plotting in Pandas. There's different styles of plots we can create. We can manipulate a number of the elements of the plots. But at some stage, if you really want to get particular about how your plot is set up, there is a need to get a little bit more control, and for that, we would need to use this pyplot module that's part of the Matplotlib plotting library. So we'll start out doing things in Pandas, and then we'll get our experience as well with Matplotlib as we start needing to have a little bit more control. At the end of the lesson, as I mentioned, we'll have a brief introduction to the Pandas Bokeh plotting library, and you're welcome to explore that more as you might like to. Now, just like last week, we are going to start out here in this lesson by downloading some data. We're only going to use data from one weather observation station here from the Helsinki-Vantaa airport, and we have a data file that's already been prepared for you. It's essentially the same thing you just download from the NOAA, like we did in lesson number 6. But here, we are going to download basically the same thing no matter whether you're working on your own computer or whether you're working on the CSC notebooks, because it's only one station. We can all follow the same procedure to download the data. Like last time, that means we're going to start out by opening up a terminal window. So I'm going to go here to File, New, and then Terminal. And I'm just going to click that to open up my terminal window. And then I'm going to grab the tab here, and like I did last week, drag it down to the bottom so that I can see the terminal and also see the lesson at the same time. In my terminal window, I'm going to start by changing directories into the Notebooks L7 directory. So we'll download the data to the right place. So we can do cd notebooks/L7. That should change our working directory into the Notebooks L7 directory. And if I just type ls here, I can see, for instance, the advanced plotting notebook and the Matplotlib notebook that we're currently looking at. So this looks like I'm in the right place. So yes, you definitely want to do this step of cd notebooks/L7 to make sure you change into the right directory. If you type ls and you see these files, you know you're in the right place, the right spot. And you can then just take the text here for this wget command, copy that, and paste it down below. This is just going to be downloading our data file. And you can see that it's relatively quick. In this case, took about 0.2 of a second to download. And if I type ls again, now I can see I have my Finland weather data L7 data file, and I can then extract that using the tar command. You can copy paste that from above if you want, or you can type in tar xzvf, which is extract, unzip, be verbose, and then F would tell we're going to give a file name after that. And I'm just going to type fin and hit the tab key, which will autocomplete the file name for the file that we want to extract our data from. So then I'm just going to press enter here. I'll see a couple warning messages here that we don't need to worry about. Those are really not important in this case. But now if I type ls, I can see there is a new directory here called data that was not there before. And if I do ls data and hit enter, I can see now that I have extracted my data into this directory, and I see 4 files, for instance, here in the list of files in this directory. If you are at that stage, then everything is good and you're ready to continue. And what I would ask at this point, perhaps, is if you could go to the participants list and just put a green check mark when you have the data available. So I don't want to rush through and move forward without making sure people have the data. So please go and put a green check mark if you've been able to do the steps of downloading and extracting the data. Okay, it looks like a good number of people have been able to download and extract the data. So I'm just going to slowly move ahead. And for those of you who are still on that step, if you have any trouble, just put a red X and someone can give you some help. I'm going to start by just dragging this terminal Windows tab back up to the top. and drop it up here so it can be out of the way, and go back to our notebook tab. Now, this data set that we're going to be using should look somewhat familiar. It's basically the same format of data that we had been using in the previous lesson from last week. And you can find, for instance, more information if you would like here, the list of stations that have been downloaded, and details about the observations at each station, as well as the general description of the data file format. All of that stuff is available on the course page and in the data that you just downloaded. And there's an example here of the first, I guess it's first 5 lines of the data file, so you can see the format. Again, this is this data file format where the missing data are indicated by asterisks, and multiple asterisks are given depending on the width of the column where the data values would normally be given. But yeah, we've seen this data file format, so we don't need to dwell too much perhaps on that. Now we're going to be getting started here with our lesson by looking at things in Pandas. So of course we need to import the Pandas library. I'm just going to run this cell to do that first. And we're also this week going to be using a date time index. And this is something we talked about back in lesson 6 very briefly. We skipped over it because it was an optional thing. So I'm just going to go here for a second to our lesson number 6, and the lesson on data processing with Pandas 2. Down here in the section about parsing dates, we had, as you might remember, dealt with our date information both as treating our date as a string of characters and slicing out a certain number of characters. But there was also this thing down there in the description about what's called a date time data type in Python, and then the Pandas functions that you can use to, for instance, convert a character string to be a date time object. And we have, for instance, some examples here of how this works. So that Pandas has this PD to datetime function, and that will take, for instance, here we're passing in an example of a column of values of time that are formatted as a character string, and then it converts that to be a date in a nice format that looks like this, where it's clearly identifiable: the year, the month, the day, and then even the hour of the day, the minute of the day, and the seconds of the day are all split out separately. And there are some advantages to using this data format that include things like you can take, for instance, your date. If it's in the format of this date time data type, you can do date.dt. This stands for date time .year, and you can see then, for instance, the year of all the values from your date directly. So you don't have to rely on string slicing and things like this. For instance, if you have data files with different formats of the string that's used to describe the date, the same code might not work similarly on those files, but if you convert them all to date time, you can do dt.year and get the year that way. Just as an example, if we go back, for instance, to our lesson here, I'm just going to add in an extra cell here. And we could say, define something here, example underscore date. And we'll put it in the format of a string. And we can say, let's do today, for example. So 2020, we'll do this in the kind of standard year, month, day format. So 4 characters for the year 2020. The month is 10. The day is 14. It's 14th of October. And let's even add the time. The current time right now is 9:58. So 0958. I don't know what the seconds are, but let's make it 47 seconds. Now, in this format here, we have defined our date as an example in what is one kind of standard format for reporting dates. And Pandas actually is smart enough to recognize some of these common data formats and how to parse them to convert them to a datetime object. So if we did some PD2_datetime with our example date that we've given here. So this will convert our date that was in this format as a string here to be a datetime object. And I'm just going to run this and hope that by going off the script, nothing bad happens. Okay. Looks like it did work properly in this case. So you can see what's returned to the screen here with this toDatetime is something that is a little bit different format than what we've seen for the output before. But this timestamp is an example of a datetime data type. And you can see in here, here's our year, here's our month, our day, and here's our time, 9:58 and 47 seconds, or whatever the number of seconds was at that time. So this basic idea of converting our dates to this datetime format is what we're going to do when we read in our data file today. And there's a reason for doing this, and it has mostly to do with the fact that in this format of a character string, even if this is input as a number, for instance, to refer to the date 2020 10/14. So let's just eliminate the time for right now and just have our year, month, day. This is fine. And if you were to plot values where you had 2020 10/14 for the date for a single observation, it's fine if it was the 15th, 16th, or whatever. But when you get to the end of the month, 31st of October, you have here a value that's going to be interpreted as a number. And the number is going to be whatever, 20,201,031 as the value that would be interpreted on a plot, for instance. And then when you jump to a new month, things are going to jump up not by a single day, but by a large number. So let me just copy this to make our example date and example date 2. So if we went to the following day in this situation, you can see the number difference between what we had previously, where things ended with 1031, is now 1101. So there's going to be kind of an unnatural gap there. Converting things to a date time, it would recognize, oh, that's only one day different. So that's kind of the reason that we're going to go with this this approach, is when you start making plots, you don't want to have things that are one day apart be spaced differently than you would expect them to be as sort of a single day difference between the plot values. If that doesn't make sense, don't worry about it for right now. But the point basically is that we're using this for the purposes of plotting, and that's our main goal with dealing with the datetime stuff. If you go into the lesson, for instance, from lesson 6 and look around a little bit, you'll find a bit more about the datetime and interacting with the datetime data. There's things about how to format. If you have data that are being read in with a non-standard format for the year, month, whatever that's given there, that can be converted to a datetime object just as well as any other thing. But you have to provide, for instance, a format string that says how the data are formatted. And you can check out the datetime and the PD2Datetime documentation to get a better sense of how some of that stuff works. Okay, so that's just a brief mention about the datetime, because if you go to the next cell, we're going to read in our data file. Here, the data path is defined for our data file. You can see we're using the Pandas read CSV as we have in the past previous lessons. And that's no big deal. We're going to delimit the white space like we did before. We got our list of NA values like we had previously, and which columns we're going to use, that's also given. What's new here is we're parsing the dates. So this parse dates parameter is used to indicate a column that contains date values. And so there we have the name of the column that contains our dates. And these are automatically going to be then read in and converted to a datetime value when the data file is read. So this basically does the Pandas toDatetime on the values in this column when the data file is read. The other new thing here is that we're using the index call. What this does is it says we want to index our data not starting at 0 and going 0, 1, 2, 3, 4 like we normally would, but instead we're going to use our date as the index. So let's run this thing. You won't really see too much. It's a big data file, so it might take a minute to read in. But as that's being read in, you can also see that there's a little bit more information down here about the parse dates and index call, how those things work, what they mean. But yeah, as noted here, this is really useful to be able to define a different index because we have values that are associated with given dates, and perhaps we want to very easily be able to refer to the year of an observation and pull all the data from that year. If you assign your date as your index, that's not a very difficult thing to do at that point. So this is going to be reading for a little while. I don't remember exactly how many lines are in this data file. Maybe while that's going, we can open up this data file and see. Maybe if it wants to open. I think it's quite lengthy number of observations here. So just scrolling down is going to take a while. So let's see if I can just jump to the bottom. Okay, yeah, there's 526,000 temperature observations here. So it's a big data file. But it does look like it's finished being read in our into Pandas properly. So now we can do something like data.head. Run that. We can see here a couple things that are different from before. So we've got temp, max, and min. That all looks fine. We've seen stuff like that before. But here you can see the leftmost thing that's shown is our year, whatever, year mode column, right? Year, month, day, hour, minute. And it's been converted to a datetime object. So you can see, for instance, the year, the month, the day, and then also the hours and the time of day that are associated with that. So you can see, for instance, here we have observations every 6 hours in 1952 of temperature. All right. At this point, we are ready to be able to do our first plot. And the first thing we need to do here in this cell is we're just going to use a little magic command here called, I think it's Matplotlib inline. So if you do %, Matplotlib inline, and that will allow us to basically tell our Jupyter notebook that we want our plots to be displayed directly within the Jupyter notebook, so not in a separate window or not saved to a file or something like that. So if you do that %matplotlib inline and do Shift Enter to run that cell, we can then make our first plot here, and we're going to do this by saying AX equals data.plot. So data.plot is the way in which we can plot something in Pandas. We have our data frame here called data.plot will allow us to plot that data. And we're just going to assign the value to AX. And the reason for doing that is because that'll allow us then to refer back if we want to do anything like manipulate the plot in some way. Again, when you run this cell, we have quite a few observations, so it may take a moment for it to run. And it may produce a slightly different looking plot than what is on the lesson, online at least. But you can see, for instance, here, our data and lots of little wiggly lines and things like that. But you can see, of course, that we have data starting from 1952 going up to 2019, I think in this case, and then temperature values that are shown on the axis on the left. So our dot plot allowed us to plot the values. And as mentioned, we assigned our data.plot to a variable called AX. If we check out the type of AX, you can run that and we see it's a matplotlib axes.subplot data format. So this is clearly a matplotlib object. And so that's our indication very obviously that Pandas is using matplotlib in the background. So we have made our simple plot here, but it's kind of not the nicest looking thing because, well, we've perhaps plotted more data than we wanted to, and maybe we have, all these different observations that makes it harder for us to see what we might be interested in, which is like perhaps how much the temperature varies in a given day. So we can do a little bit better. And we can take the temperatures, for instance, from the 1st of October 2019. So we could say oct1_temps equals. Here, we're going to take a selection of values out of our data frame. So we have our data frame and our variable in there called temp, which contains our temperature values. And now we'll use the .loc to find places where the data.index is greater than or equal to, and now we'll put something in the format of a string of the year, month, day, etc. So 2019, 10/01, and we are going to take our data only from the afternoon, and in this case, we could then say the date should be after 12/00. So this is the year 2019, month of October, first day of October, and then noon. So this will give us a selection of values from the temp column that are from time of noon or afterward on the 1st of October. And our last observation is at the end of the day on that day. So we should have only one afternoon worth of data there. Then if we do an AX dot, or assign again our value AX, the oct1temps dot plot. So basically like what we did before, this is a data frame that we've created with our selection of data. Now we'll just plot that data frame. You run this, and now we can see how the temperature varied in the afternoon or between the afternoon and midnight on the 1st of October 2019. So we made a few little modifications. One thing you can notice here is that our index is a datetime object, but it's still understood when you give this string. That's when you want to do the comparison that you're trying to compare against the date given in the format that's in the string. So Pandas handles that one no problem. And then we plotted our data like we did previously. That's our basic plot. We can do perhaps a little bit better. We can add some kind of formatting things here. So if we go back to plotting like we did before, we can say AX equals oct1temps, and then dot plot once again. So similar approach to what we did before, but let's give some additional information. For instance, we could say style. And in this case, we can say style equals RO dash. This is a shorthand notation for the style of the plot that indicates it will use a red line. It will display symbols, like basically a circle for all the data points. And then the line connecting the data points will be a dashed line. So the 2 dash would indicate you're wanting to use a dashed line. We can also add a title here. And we could say, I don't know, Helsinki, Vanta temperatures. So that will add a couple things to our plot, change the format a bit. Now that we've defined AX, the reason for doing this will be a little bit more apparent because we can do things now like AX.set_X label. This will set the label for the X-axis. And we can say that's going to be date because we know the values on that axis are date. We can also do AX set Y label. Here, this is going to be temperature. And this can be degrees Fahrenheit. If you don't know how to do the degree symbol, you can just do an F. Doesn't really matter for the purposes of our demonstration. And if I just do Shift Enter now, our plot will look very similar to what we had before, but slightly different in the sense that the formatting has changed. We now have a title up here. You can see the title that we defined. We have axis labels that we didn't have previously. And of course, our plot line is now, instead of being solid blue with no markers, it is a red line that's dashed with red circles as the marker. So there's a bit of an explanation here about how we formatted things a little bit. But we can also find more information if we use the help that's available. And if we do help for oct1 temps.plot, this will give us the information, the documentation about the plotting that's built into Pandas data frames. So if this, as long as this is the data frame name here, we could put data.plot, but we'll just do oct1.plot because we have just plotted that data. If I run this cell, you're going to get a lot of stuff written out to the screen, but this is basically telling us how to do and how to manipulate plots that we're creating in Pandas. So the expectation would be that normally you would give something .plot to get to using this plotting functionality that's built into Pandas. And then here you have different kinds of parameters that you can give. So you could say, for instance, the data frame, if you didn't do data.plot, you could, for instance, give a data frame you want to plot. You can define the value you want to plot on the x-axis or the value you want to plot on the y-axis separately. You can define the kind of plot. So we'll see an example of a different kind of plot at the end of this lesson. And there are lots of other things that you can give here. For instance, if you want to display a legend, how you want to format the style, whether you want to use log scaling on the plot axes and the limits of the x and y axes and things like that. All of that can be defined, and it's all described in the help here, how to use those different things. You've got to scroll down a ways because there are nice examples and things like that that are all built in here. So we'll do a little bit of scrolling to get back to where we are in the lesson. The point is, if you do help dataframe.plot, you can find more information about plotting. We can also make the plot size larger by default, or use the embiggening term from the Simpsons vernacular. Here, what we're going to do is, in order to change the default size of the plots, we have to use Matplotlib. So Matplotlib is used in the background, and we don't have to import it to do the basic plotting in Pandas. But in order to do things like change the default size of the plot, we're going to have to import the Matplotlib pyplot library. That's done here as matplotlib.pyplot. And traditionally, it's imported as PLT. So that's if you look around and find examples of plotting online with Python, very often you'll see this first line here as the start of those plotting scripts. Then we're defining a thing here that's a sort of, it's like a default value that's used in Matplotlib for the fig size, so figure.fig size of 12 inches by 6 inches wide, because Matplotlib was developed in the US and inches are the standard unit of measure for small things. That is 12 inches by 6 inches. I guess it's really because it's the size often used for measuring things on a piece of paper. If you want to lay out a figure on a page, you kind of want to know how big it is in inches oftentimes. That will default, or sort of change our default value for the size of the figure. You could go back up and run one of the plot cells again to see the now bigger plot, but we'll make another plot here in just a second so we can also see things that way. So there's a few extra things we might want to add to our plot that are described here. We can add text to the plot. So we have the possibility to do ax.text and display some text on the plot at some location xy. So in this case, the x would be some date, the y would be some temperature value, and then the text to be displayed would be in quotation marks here. We can also change the range of the axes, and this can be done by defining xlim, which is the x limit, which should then be a Python list with a minimum, comma, maximum value, and the y limit, same general format. And then we have to deal with one challenge related to our date time index. As we saw before, we had this example of converting things to date time from a character string. So we have this character string, for instance, up here, and we did pd.toDateTime. And then we had our character string, which I'll just copy paste here. Let's see if we can copy that and paste it in here. So this should be 2019, the month of October, 1st of October, and then 1 p.m. or 1300 hours is the time. If we just run this cell, we can see that gets converted as you would expect to a date time format. And the reason for mentioning that is let's do some further modification of our plot where we want to define a time when we start plotting our data, a time when we end our data plot, and then the range of temperatures to show between 40 and 46 degrees Fahrenheit, and then we can add some text to the plot to show the coldest part of the early afternoon. In order to change our X limit to start at noon and to end at 3 p.m., we need to basically do this PD to date time conversion. So let's do that here. So our start time, we can say is PD to underscore date time. And it's supposed to be 12 noon on the 1st of October, 2019. So 2019, 10 for the month, 01 for the day, and then 12:00 for the time. That's going to be our start time for when we will have our data plotted. We have an end time as well. And our end time, again, will be PD.to underscore date time. You can copy paste this and edit if you want to do things that way from what's above. Again, 2019, 10:01, and then here 15:00 because it's 3 p.m. that we want to have there. And lastly, we're going to define our cold time. So this is the coldest time in the day. In this case, I happen to know that it's basically 12 noon. That was the coldest time on this day. So we'll do again, PD to date time. 2019, 10:01. And I'm actually going to do 12:05 here because I want to have my text slightly offset. So 5 minutes offset from the point where the values are plotted. You'll see why in just a moment when we make the plot. Then we have our AX equals oct1 temps dot plot. Here's our style. Here's our title. We had those things before. We want to use the xlim and ylim to define the range of values that are shown on the plot. So here we can say our xlim equals, and I guess I won't put any spaces because that's how we'll do it, start time, comma, end time. So this should be a Python list. It should be in the format that xlim equals 2 values in a Python list, and we want to start with our start time, end with our end time for the limits of the x-axis values. And similarly, we can say for the ylim that it's also equal to a Python list, in this case starting at 40.0 and ending at 46.0 for the values on the vertical axis of the plot or the temperatures. Then we've got our X label and Y label that we had before, our date and temperature. We need to add some text to the plot, so we can do that using ax.text. And this will be at our location along the x-axis of our cold time. Location along the y-axis is going to be at 42 degrees. Just happen to know that's what the cold temperature is in this case. You could always do this as a sort of guess and check or trial and error method. And then we're going to say, make a little text arrow to say coldest time of the afternoon or the early afternoon. Okay, so we've defined our start and end times. We're now setting these limits to show when we should start and end our values that are plotted. And we've added some text here that's going to be displayed on the plot at the value of x equals cold time, y equals 42 degrees. Let's run this thing and take a look. So for one, you can hopefully see the plot size has gotten a bit bigger. You can perhaps also see now that we're starting here on the 1st at 12 noon and ending at 15:00, so 3 p.m. as expected for the date range that's shown here. Our temperatures go from 40 to 46 degrees as expected as well. And then we can see our text for the coldest time in the early afternoon Perhaps you can also see why I've just offset that slightly from where the point is, just to make things a little bit nicer looking visually. And that is that. I've been chatting now or talking now for a while, and this is a good point perhaps for you to get a break from hearing from me and to try to apply some examples of what we've just seen in your own plot. So we create here a line plot that's similar to the examples above with the following attributes. It should show data from 1800 to 2400. So basically from 6 p.m. to midnight on the 1st of October. You should plot this with a dotted black line connecting the observations. So don't show the data points in this case, only the line. Have a title that reads evening temperatures on October 1st, Helsinki Vantaa, and then a text label indicating the warmest temperature in the evening. So I'm going to go ahead and clear out the check marks, and you can take the example from above, modify it to make a plot that has the following pieces here. And when you've done that, you can check the green check mark, and we will continue from there. We have a few other things I'll show briefly after this, and then we'll take a break. But let's do this first, and we'll review it and then finish the lesson and then have a little break. But for right now, just hit the green check mark when you've got your plot formatted as suggested here. So I see a few people have put the green check mark, and I don't mean to rush too much, but unfortunately we are going to be running a bit tight on time. So I do want to maybe move ahead here, and I'll walk through the example. If you're still working, you can of course continue doing that, but I think it's good that we start moving on. And so I'm going to start here by copying our example from above down into this cell that we have here, and then we'll make the modifications as necessary. So first off, our temperature data is supposed to go from 6 p.m. to midnight. So here we are with our start time. Instead of being 12 noon, it should be 1800 for 6 p.m. And instead of our end time being 3 p.m., we're going to go until the second at 0000. So midnight at the start of the day of the second. We don't know yet what our cold time, in this case it's going to be our warm time, should be, but it's probably going to be somewhere within this time range. So we can at least say that on the first, let's put this at 1805, just to give us a starting point for guessing what the warm time is going to be. Now, that's taking care of our range of temperatures. It's supposed to have a dotted black line connecting the observations. So here we're going to know that we need to go modify our style. K is the letter that's used for black. In case you were having a hard time figuring that one out, it's not exactly intuitive, and I'm sorry about that. But if you put a K and then a dot, that will give us the format of a dotted black line. Our title should be evening temperatures on October 1st. I'm just going to copy this from above and paste it in here. Easy enough. And a text label indicating the warmest temperature in the evening. And we'll just say warmest time of the, and let's just say evening. Now, if I run this, we get a handful of things that look good. I did not get a dotted line because I did not put the right format here. I put only the dots. I think it's actually maybe this to get the dotted line. So it's K and then a colon character to do a dotted line. It looks like our temperature range is generally okay. Our text here is not shown in the right location for our cold time because we had cold time and we should have warm time instead. Bokeh has kindly provided a link to the Matplotlib documentation to get some more information about formatting the plots. But I just want to rerun this one quickly with our warm time. And we can see there's a couple issues. For one, our range of temperatures doesn't seem to be right. So it looks like our maximum temperature here is about 43 degrees, but there's colder temperatures that we can't see. So that tells us our Y limit needs to be adjusted. So let's make our maximum value 44. Let's make our minimum, I don't know, 37 and just see how this looks. Run the cell again. 37 is not cold enough. Let's go 35 and see how does that look. That looks fine for the Y limit. We're supposed to identify the warmest time of the evening, and it's obviously not at 6 p.m., but instead it looks to be something like maybe 10:40 p.m., something like that. And I am going to then change my warm time to be something like, I would be tempted to say 10:40, which would be 22:40. Again, we'll just run this to see. But we also know that the warm temperature looks like it's about 43 degrees, not 42, so we can change that to be 43 degrees as well. Run that. Things look kind of okay. It's maybe not quite 1040, maybe it's 1050. But obviously, with our line being plotted over here on the right, maybe it's better that we position our text somewhere a little bit further over to the left and then have the arrow pointing to the right. So let's do that. Let's make our arrow be at the end of our text on the right side. And let's put our warm time, instead of being here 10:40, let's make it something like maybe 9:30. So 21:30 and see how things look. Not quite. So let's go 21:20. Run this again. Okay, not too bad. So here we have our dotted black line as we expected, and things are generally looking like they've ticked all the boxes for what we're supposed to do. Temperature, time, like the range of times is right. The dotted black line looks good. We've got the right label here for the title, and our text label now points to the warmest time of the evening. Okay. Now, in order to give Woko some time to show you some other things, I'm going to go through these last couple pieces here somewhat quickly. One is just to indicate that you can create bar plots in Pandas, and some things you have to handle a little bit differently when doing a bar plot, but there's an example here of a bar plot for our temperature data. And if I just run this cell, you'll see an example of how you can create a bar plot. I think maybe that's all I'm going to say about that right now, other than the way we change the style of plot is to include this kind parameter. So we say kind equals bar, and we can take the same data frame we had before and now plot our data in a little bit different way. So that's kind of a handy thing to do as a way of showing our data. We can also do things like save our plot as an image file. So far we've been putting all our plots into Matplotlib and in Pandas and having them displayed directly within our Jupyter notebook, but we can also save those plots as image files. It's rather straightforward to do that. If you've already imported Matplotlib, as we have, we can then save our file, for instance, as a PNG file format. It's a good file format in terms of raster graphics. It's a nice style that we can save our plot in by doing plt.savefig. This is then expecting us to provide a file name, so we could say bar-plot.png. And Matplotlib will recognize, based on this file extension, that you want to save the file as a PNG file. And if we run this, just do Shift-Enter, it makes and displays our plot, but it also saves it to a file. And if we go here to our file browser over on the left, get out of our data directory, just go back here, you can now see you have this bar-plot.png. And if I double click on that, sure enough, there is the bar plot that we just were creating. Just as another demonstration here, we can save also as a high resolution PDF. Again, doing plt.savefig. In this case, we're going to give our file name bar-plot-high-res for high resolution .pdf. So we're going to use a different file extension here. Now this is going to be saved as a PDF file. And we're also going to include this parameter DPI equals 600. So this will set this to be a high resolution with 600 dots per inch as the raster resolution. Again, you run that cell, the plot gets displayed, and over here on the left, if we just click the refresh button, we can now see our bar plot high-res.pdf. Double click on that one and looks good. So we can clearly see our nice high resolution picture, our PDF. We zoom in, you can see that the text is rendered as a raster in this case. You can see just a little bit of fuzziness around the outside of the letters, but it's quite good resolution at 600 DPI. Okay. Finally, there's a little bit of stuff here about doing interactive plots with Pandas Bokeh. And again, I'm just going to run these cells and just tell you very briefly what they do. So first, we're going to import the Pandas Bokeh library. And then there's some configuration steps here that are needed to tell the notebooks that we want to plot using the Pandas Bokeh library. So if I run that cell, hopefully if you do the same, you see this Bokeh.js 2.1.1 successfully loaded. And then on the bottom here, if I run this cell down here, we have Helsinki Vantaa temperature data. So you can see our title showing up here, our axis labels, nice looking format for the date information that's shown there. And you can also see, for instance, here, how now if I move my mouse along the plot, it can show me the temperature values on the plot as the mouse moves along at these different times. And we can also do things like if I want to zoom in, I can just zoom in a little bit. I can click and zoom to some location and see things there. I can click this reset button to go back to the original view. And I can also click on things in the legend to turn them off or on for items being displayed on the plot. Just going to run the other example that's down here on the bottom, and I'll suggest that maybe you go and read through some of these things if you're interested to see more information about Pandas Bokeh and the plotting that's done there. But again, if I move things along now, what's different here is I've now added the points to be displayed as well as a line connecting those points. And so now if I put my mouse up here, I can see, for instance, the max values in temperature at different times, as well as the minimum values in temperature at different time. If I didn't want to see those, I could just click on the max and min and hide them. And again, if I want to zoom into temperatures in some certain window, I can just click and zoom and drag things along as I like. I'm zooming in again, but I could also click this little pan button, zoom out maybe just a little bit with my trackpad that I could pan and drag along. And obviously it's nice to be able to interact with the data in this style. In what format is the bokeh plot saved? That's a good question. I don't actually know when you export bokeh plots. I think it may be possible that they export them in some way to HTML with some JavaScript. Yeah, so as Volko is noting here, you can export them as HTML. I guess if I go here and click the save button, it does give me also the option to save as PNG. I don't have any idea what that looks like. I guess I can save the file and open it up. So there's our little piece of our plot that I guess we're zoomed into that I saved. So it looks like you can also get PNG files out of there, but the way to export them normally would be to export as an HTML. There's more information about how to interact with Bokeh and things like that you can find online. And this is just to show us an example of how to do these interactive plots in case you're curious about making things like this. It's very cool stuff, but it gets to be a little bit more advanced, and we want to kind of stick to teaching you the basics of plotting in this lesson. So if there are not any questions, I think I will maybe stop here and let Volko take over, because she has definitely some very useful things to show you. And I hope that I have left her enough time to do so. But yeah, are there any urgent questions at the moment. Okay, then I will stop sharing my screen, and perhaps Vuokko can start sharing hers.
I guess we want to have a break, right?
Oh, right. Yeah, obviously I'm mentally in need of a break as well. So yes, you're right.
Yeah.
We should definitely do the break. And can we keep it to no more than 10 minutes?
Yes, let's do that. And it's not a super long lesson after that. So I'm sure we'll have enough time to go through everything. So let's be back at 10:55 sharp. So I'll continue then.
Yes, sounds good.
Okay.